Hi there and welcome to the FAME Project Carbon Footprinting tool. In this video I'll give you a quick overview of the tool structure, and then for specific details on how to enter the data please look at the later videos in the series. Firstly, I just want to mention that for best usability the tool should be used on Excel 2021 or later on Windows. So the tool was constructed to help archaeology organisations respond to the requirements of PAS 2080. Ultimately, the requirements are to create project-specific carbon footprints, both forecast and actual footprints, so that performance can be analysed. The forecasted emissions will be used to set clear baselines, identify the high carbon emitting activities. Using this information, you can then set appropriate targets and track the results of any carbon reduction activities. Let's start with the dashboard, which is the main tab for viewing your carbon footprint calculations. This tab summarises emissions based on data that has been input into the tool, and you can use it to view a footprint for the whole company within a specified time period, a specific project within a specified time period, a client, so a summary of all projects undertaken for a specific client, and similarly a whole location, so any projects that are being completed within a specific location. And also from the dashboard you're able to export CSV files which can be sent to clients if required. So the rest of the tabs are colour coded to make navigating the tool easier. So you have an orange tab here to let you check what data has been entered into the tool. You have blue tabs which are for data you'll input regularly, like monthly data or quarterly updates. And then you have yellow tabs are for things that don't need updating so often. So this is, for example, office inputs and projects that you want to report on within the tool, and also for custom carbon factors, which will be covered in a later video. And then finally you've got green tabs that house the databases, so you won't really need to use these very often. They're mostly for auditing purposes so that you can check what factors were used for each calculation and how the calculations are done. So there is a chronological process for inputting data to ensure that the tool functions correctly. We've put a flowchart on the intro page to make it as clear as possible. So the first step is to input your office locations, then the projects that you wish to report on within the tool. So this does not need to include all projects undertaken by your organisation, simply the ones which you want to use the tool to report a project footprint for. After you've done that, if you're wanting to use any custom carbon factors, for example using supplier specific data, then for any of the calculations then you'll need to input these before inputting the data. As I said earlier, custom carbon factors will be covered in a later video, so don't worry if you're unsure what they are. And then after the basic data has been input, you must enter total organisational project person days, followed by the project specific person days. It's very important to do them this way round, otherwise the allocation methodology will not function correctly. Again, covered in more detail in the person days input tab. Once all of this has been done, you can begin to enter the rest of the data. So your bill of quantities, your project transport, your soil and excavation, and your overheads data. These will need to be input on a regular basis as time progresses. And then if you want to report on a project, you should then use the data input check tab to ensure that the data input is complete. And then you can export the CSV file from the dashboard. So there are a few recurring themes that you'll come across regularly when using the tool. First of all, you've got forecast versus actual data. So the tool helps you to meet the PAS 2080 requirements by distinguishing between forecast and actual data. So forecast data is used to calculate projected emissions, and actual data tracks the project's carbon emissions to date. So this will allow you to compare actual emissions with your forecast emissions to monitor carbon performance over time. It's worth noting that data inputs can change between forecast and actual reporting. For example, you might initially forecast company vehicle travel in miles, but then later update this with actual fuel consumption from telematics or fuel card data. So the important thing to note is that the units you use for forecast data do not have to match the units used for actual data. So if we go to the dashboard, you can see here that that the forecast and actual emissions can be seen in these two columns. The next main theme is development emissions. So you can see these at the bottom of the table here. So the tool separates purely archaeological emissions from development emissions to ensure that the archaeology industry is not assigned an unfair proportion of a project's emissions simply because they're the first people on site. If the area will not be developed as part of the wider project later in time, it should be classified as purely archaeological activity. However, if the activity happens during the early stages of a development project but the land will be permanently changed at the end of the project, such as, for example, converting a pasture into a road, then these should be classified as development activities and consequently development emissions. Further sort of definitions on this are provided in the soil and excavation input tab. Finally, the last overarching theme of the tool is to do with data resolution and quality. So whenever possible, the tool encourages you to use physical activity factors as these provide the most accurate carbon footprint calculations. However, we do understand that this is not always possible. So to help, the tool offers flexible data resolution options, and there are flowcharts in relevant tabs to show you the preferred formats, and you can also refer to the methodology document for more details. But generally throughout the tool we're using a traffic light system to highlight the data quality. So we've got green is the preferred choice, this is the most accurate. Amber is acceptable option but less precise, and then red is the least accurate and should be avoided if possible. If you are entering data in multiple formats, the tool will ask you if it's double counted or if it represents separate activities. So you just need to take care, because entering the same data in multiple formats, so the data for the same activity in multiple formats can lead to an inflated carbon footprint. And so you just need to ensure that they're representing distinct activities. As your project progresses from forecast to actual emissions, you should be aiming to provide data in the preferred format wherever possible. So I did just briefly mention the methodology document, but if you want to understand deeper the methodology behind the tool or need something clarifying, then there is supporting documentation. You can look at the transcripts for these videos and also the methodology document, which will have flowcharts and explain the process of all calculations that are undertaken in the tool. And so I'm going to quickly show you an example of an archaeology organisation's carbon footprint. So we have synthesised this pie chart based on our work with some of the larger FAME members to show what we expect the majority of archaeology companies' footprints to look like. We expect the goods and services which archaeology companies purchase to take up the largest proportion of the footprint. So this includes plant hire, project cost, accommodation, vehicle hire, computer consumables and other purchased goods and services. So we can also see that in addition to the purchased goods and services, commuting is also a significant contributor. So essentially, the activities of an archaeology company can be separated into two categories. You have your project activities that include, for example, fuel consumed by plant equipment or transport to and from the project sites. And you also have the overhead emissions, which include electricity, waste, commuting, any sort of emissions resulting from activities within your offices. So even though we're reporting a project carbon footprint, if we only account for direct project activities, we would exclude a massive proportion of the corporate carbon footprint, namely these overheads, which I just mentioned. So looking at this pie chart, we can see that commuting is a large contributor to the overall footprint. So if we only accounted for project activities, we would completely overlook this significant reporting category. The tool therefore requires overheads to be input in addition to project-specific activities, and we've developed an allocation methodology that splits overhead emissions between projects that is further explained in the person days input video.